question 12. So I think this is a really nice trig identity question. Remember, you've got two identities that you can use, and both of them are going to be useful here. Tan x is equal to sin x over cos x, and sin squared x plus cos squared x are equal to 1. So first of all, we need to get rid of the tan in here by just rewriting it as 4 sin x over cos x equals 5 cos x. Then if you multiply both sides by cos x, you get 4 sin x equals 5 cos squared x. And the game is taking it all into sins, which we can do by now using the other identity about sin squared plus cos squared. So that means that cos squared x will equal 1 minus sin squared x. So then you're going to get another mark for writing 5 brackets 1 minus sin squared x. Don't jump that stage. You really do need to show that. Then we expand the bracket. 4 sin x equals 5 minus 5 sin squared x. And then we're just taking that and adding that. So at that point, we can just say 5 sin squared x plus 4 sin x minus 5 equals 0 as required. And then when it says hence solve this equation between 0 and 360, that means we're going to use this because this is a quadratic equation. So we're going to start off by saying, so this is part B, let u equal, or any letter you like, but u equal sin x. Therefore, 5u squared plus 4u minus 5 equals 0. And this is I think it's our fourth opportunity to do a bit of factorization with coefficients of x squared. So that's negative 25. So we're looking for numbers whose difference is 4. It's not an opportunity to do that, is there? Because that is no. We've only got 1 and 25, difference is 24. 5 and 5 difference is 0. So we're going to need to use the quadratic formula to do that. So u is going to equal negative 4 plus or minus the square root of b squared is 4 squared minus 4 times 5 times negative 5 all over 2 times 5. And if you whack that into the calculator, you're going to get u equaling negative 2 plus root 25 over 5, or u equaling negative 2 take root 25 over 5. Sorry, miscalculated from my calculator. It's root 29, isn't it? Not root 25. Of course, root 25 would have been 5. Now, this is going to give us a positive number, but this is going to give us a negative number. So we don't want that. Sorry, it's not the fact that it's negative. It's it's always a good idea to double check. Although you're going to use those values, that would be 0.677. But if I go into my calculator and I jimmy back through to here and I turn that into a minus, I'm actually getting negative 1.47, and that's often not possible to spot in the third form. And obviously you can't have sin x being worth more than or less than negative 1 or more than 1. So for that reason, we're going to be crossing that out. So sin x is only equal to -2 plus root 29 over 5. And that means that x would equal, if you do sin to the -1, you get x equals 42.6 degrees to 1 decimal place. So then we just need to consider our sine curve, and we're going to if we've got 42.6 there, we're also going to have one in there at 180 minus 42.6 would give us that. That's 360 degrees there, isn't it? Which is 137.4. So x equals 42.6 degrees or 137.4 degrees. And finally, we come on to part C, which trips a lot of people up this question. What about if we just had the same thing, but it was tan 3x? Now you need to consider what sort of stretch happens for 3x. One thing you can do is pop that into the calculator if you're a bit confused to help you think it through. So let's do that. Here it is, sin 3x. If I hit draw, if I hit, oh, there we go. And it's not going all the way up to 1800, but it should do enough for us to be able to extrapolate it. So we're going from 0 to 360, and see what's happened. We've got 1, 2, 3 whole waves happening within it. So the transformation that happens is a stretch of scale factor -1/3. So the way I would often do it would just be to multiply 360 by, multiply that. So what we're going to have is we're going to have 3 times, so it was 3 waves times, if you do 1800 divided by 360 equals equals 5, and then we're going to have in each set of those we're going to have 3 times 5 waves, which means 15 times the 2 results equals 30 solutions. And in order to show that, you might want to just do a quick, because it does say, explaining briefly the reason for your answer. So I would just draw a thing here showing that I've got, and I would have I know it's going to be 3 waves within my 360 degrees. So if I do, and then put 360 degrees, scale factor -1/3, I've got, then that's going to be enough to explain why I've got there. Okay.